Quadratic looks like a scary name, but quadratic simply is a name for a polynomial that has a squared as the largest exponent. Okay, a squared is the largest exponent. So you're going to see stuff like x squared minus 2x plus 5. This is a polynomial, and we're going to talk about polynomials more. Yeah, we haven't talked about them yet, have we? Polynomials. This is a term. This is a term. This is a term, okay? And you'll see all that in polynomials. The main thing that I want you to know today is that a quadratic is a polynomial that the squared, or the 2 as an exponent, is the largest exponent, okay? So quadratics. Now, what we're going to do today, there's a lot of things you can do with quadratics, and we'll hit that in the quadratic section. But right now, we're going to do our first step in solving quadratics. There are several different ways that we can solve quadratics, but today we're going to solve it by the square root property. Now, you don't necessarily have to memorize this phrase, but I want you to know this is what we're doing today. We're solving a quadratic by using the square root property, okay? This simply means that we're going to be taking the square root to find the answer. Ta-da. Okay, so it's easier for me to just explain. So number 1 on your worksheet looks like this for those of you that came in later. Square root property, okay? And we're doing number 1. It says solve each quadratic equation by using the square root property. And that means we're just going to find the square root. All right. Now, before I start, I want to remind you that when we started learning how to solve equations, we knew that you had to do the opposite operation to get rid of something, right? And so we said that if it was a plus and we wanted to get rid of it, we had to do a minus, right? And if it was a multiplication and we wanted to do the opposite, we had to divide. Yes. Well, there's one more that is harder to remember. But if we have something squared, then we're going to have to take the square root. These are opposites. Okay. The same way, we're not going to do this today, but the same way here is the opposite of cubed is a cubed root. Okay. So if we have an exponent, we need to take a root. And backwards, if we have a root and we want to get rid of that, we need to square it. Okay? All right. These are opposites, and this will come in handy today big time. So we know that in solving, we put a line down through the equal sign and circle the variable that we want to solve for, which is what we've been doing all along. And since this is what we want to solve for, we need to get rid of this. This is a minus 12, and so we're going to add 12 to both sides to get rid of that straggler right there. And then we have n squared left equals 12. Now to this point, we're not circling the n squared. We want to solve for just the n. So now we have to get rid of the squared. Okay, so we just found out that if we have something squared, we have to square root it. So I'm going to square root this side, but remember you have to do the same thing to the other side. Okay, so now we have n equals the square root of 12. Now I want to go on to tell you, and I'm not sure if this worksheet goes into this. Yes, it does. I want to explain to you that when we take the square root of something, square root of something, square root, the answer, there are actually two answers. there is a positive square root of 12, and there is a negative square root of 12. When you take the square root of something, you always have the positive and negative answer. Okay? So on this worksheet, they're going to write it like this, plus or minus the square root of 12. You just need to know that this means there's two answers, this one and this one. Now we're going to go one step further, because we don't leave radicals, now that we know how to simplify them, we don't leave them like this. We need to simplify it. And so we're going to use our method 4 and 3, 2 and 2. And so our final answer, I can get rid of all this extra confusing stuff. Our final answer, since we're finding square root, will be plus or minus. And then we've got a set of 2's that can go out. Oh dear, can go out. And the 3 has to go inside. And so plus or minus 2 square roots of 3 is the final answer to this. Did y'all follow it okay? Okay. This is the square root property. This thing is called a quadratic. So this is our first step in learning how to solve quadratics, okay? Any questions on this one? Not yet?
Is it add or subtract when you have your 2 or 3? Does that still, do you still put anything on top of that, or just on the sides and in?
This 2?
Yeah, just put
It's supposed to go like this. Plus or minus 2.
That's it.
Mm-hmm. But it's a good question because I crammed it all up, right?
Well, no, I got that, but I was wondering if you put like another answer on top. Probably.
No.
Okay.
The end. Okay. Let me look on this page and see if there's something that might confuse you. And it doesn't hurt to do another one real quick. Oh, I remember one that you're going to need. This one. Let's do number 7. I'm going to do number 7 now. Okay, this is going to bring two things, two new things to your mind. Here's this. We want to solve for the y, but notice that this is parentheses, so I can't go up in here and get this 2. I have to get rid of the squared first, okay? So I'm going to square root it, because squared and square root cancel each other out, okay? I'm going to square root this side. So now I have y plus 2 equals the square root of a -9. What did we find out about the square root of a negative? Square root of a negative.
They also have positive.
You can't do a square root of a negative, okay? So this one will be no solution, because it's not possible. If you're going to square root this side. Now, the one thing, the two things that I wanted you to see was that you remember you can't take the square root of a negative. But the second thing I wanted you to see is that if it's a parenthesis squared, you have to get rid of the square root before you can get rid of the 2. Let's do one that you actually can. Okay, are y'all doing okay? Josh, Sherry?
Yes.
Okay,
Yes.
no questions then.
No.
Not at the moment.
Okay, now this one, I want you to see how it works. And we have to remember on this problem that I'm going to do for you, you have to remember that when you take the square root of something that's possible to take the square root of, then it's always a plus or a minus answer. So you're going to have two answers. Okay, let's look at number 3. Okay, k minus 6, and it's in parentheses squared, so you can't come up and get this out of the parentheses. You have to, one of my tutor students said, I said, it's like it's in a barn or a building, and you have to open up the building. And she said, oh, I'll just blow up that building. I'm just going to blow it up so that she can get the 6 out of here. But this is caged in here. You have to get rid of the squared, which is locking the building, okay? And before you can get to this. So if the squared is the only thing on the side, now it's time to take care of the squared. And the opposite of squared is square root. Square root, okay? So on this side, we just blew up the building, okay? Because the squared and the square root cancel each other out. And I have a k minus 6 equals. Now, be careful here. It's going to be 7 and a negative 7. You guys know you can write it as plus or minus, but I want you to see for sure that there are two answers. So whenever you solve this, I would suggest that you write it separately, but what's happening now, if you want to solve for the k, you have to add 6, right? But that means you have to add 6 to either answer. So we're going to add 6 here, and we're going to add 6 here for two different answers. So now I have that k can equal either 13 or negative 1. A quadratic, so many times, not all the time, but most of the time, will have two answers. Okay? It can have one answer and it can have a no solution like we just saw. But the majority of the time, you're going to have two answers on a quadratic. Okay? So here's the answer here. Did you all follow what was happening here?
On this one, yes. On the plus and the negative. Oh, you know what? Never mind.
Are you okay?
Yeah.
Okay. Because any square root is going to have a plus and a negative answer. You're going to have to remember that now from now on. Okay, because that's going to happen in all the quadratics that we're going to do in that section. All right. Let me see if there's anything else here. Let's look at number 9. Number 9, and then we'll go on to absolute value. Washcloth were much better than our erasers. When I write it up here, I'm going to give you all a head start. I want to see what you do with this problem. My nose. Number 9. Okay. I'll explain the answers. So did anybody get a solution yet without looking at the back?
This is going to W is W equals 22.
well, W squared
Yeah.
equals 72. So what does W equal?
One.
How do we get rid of a squared? How do we get rid of the squared? By square root. That's exactly right. And what do we know about square root of a negative? No solution. Now, all of you, Sherry and Josh, I think you guys got this in the email. Look at the answer to number 9 on the back. Okay. Does it have this, or is it? It might.
It shows W equals plus or negative 6.
Mm.
And then
Okay.
I.
W equals, and then they took 72. Hi, Sally. I am better, just not 100%. No, I'll visit with you later. Okay. And so we are, but this is a negative, and we know that we can't get a real answer. So we're finding out if we do all of this like we always do, then we have a 2 out here, we have a 3 out here. I'm letting you know how they got the answer. Okay, and so W equals plus or minus 6 square roots of 2, but if you notice, there is an I out here. That's how they deal with the square root of a negative. Remember when I told you we have all real numbers, and that's what we've dealt with. But I told you there is another section called an imaginary number, right? An imaginary number, this is imaginary. So this is really not a real answer. This is how they deal with this negative under the square root. Now, in saying that, I wanted you to know how they got the answer on the back. But if you see any of the answers with the I am fine if you just say no real solution. Be sure and put real in there. No real solution. Okay, because in the GED education part, I don't think we ever deal with imaginary numbers, so you don't have to worry about it. But I want you to know what this means. Okay, that's how they deal with the square root of a negative, but it's not a real answer. It's an imaginary answer, which is comical to me, but it is what it is.
So the real one is like the W negative plus.
But when you get to this part and it says the square root of a negative, you can stop there. I only went on to show you why the answer on the back is this. All right? But when you get to the square root of negative, you just tell me there's no solution, okay? Because we haven't done imaginary and I don't expect us to. Everybody okay? Josh, Sherry?
Yeah.
Oh, I'm sorry. You guys didn't see this. I want you to see the I. See it over there? The I, that's how they take this negative out from under the square root and put it out there. And it indicates that this is an imaginary number. Okay, and we're not going to deal with imaginary numbers. Okay, let's look on the worksheets that I gave you, the page 1 and 2, and see if you see anything that you might want me to work before we go to absolute values. And let me check and see if there's anything else that might bug you. I think they're all okay, okay? So page 1 and page 2, you guys should be fine. Now we're going to talk about absolute values. Now, absolute value simply means, okay, if we have an absolute value of, let's say, 5, absolute value, this indicates how far from 0 it is on the number line, okay? So 5 is 1, 2, 3, 4, 5, okay? Right? But absolute value does not care about direction. So it doesn't care about positives and negatives. So if I have an absolute value of -5, it still tells me it's just 5 spaces from 0, okay? It's 1, 2, 3, 4, 5. But it's like saying, I'm taking 5 steps. You don't take -5 steps, right? Okay, so an absolute value just indicates how far it is from the 0. Doesn't care about negatives and positives. So the bottom line is that anything that is inside the absolute value, if you have anything absolute value, the answer will always be positive because it's 5 steps from 0. Okay, y'all see? Absolute value does not care about the direction. So let's look at this page, page 3. And on this page, it just wants you to get used to using absolute value. So let's look like we always do. We'll look at number 1, and then I'll look through and see if you need something else. Now on this page, all you're doing is evaluating the absolute value equation by using the value that they told you. Okay, so this says f of x, and I think we've talked about this before, but maybe not. F of x, just a minute, let me get it all on here. Okay, and it simply says to evaluate this equation right there. Okay, they call this a function, which is an equation, which I call a rule. You can have any rule. You can have m of x, or k of x, or p of x. They just name different rules. This is rule f, okay? And this thing simply says, my rule is going to have a bunch of x's in it. That's all this is. It's a title. This is the rule. This says what's going to be inside the rule. It's going to be a bunch of x's. It could be f of a, and all those things would be a. Okay? Now, in this case, it says, I want you to use x equals -1. So what we're going to do is say, I'm going to use the f rule again, but I'm going to plug in -1 where the x was. So I'm going to come here, I'm going to write everything down, but when I come to an x, I'm going to plug in -1. Okay, and when you're solving an absolute value, put those in the same position as parentheses. You know, when we do, please excuse my dear Aunt Sally. Okay, and we do parentheses first, we'll do absolute values first, just like you would do parentheses first. So this part right here, absolute value of a -1 is equal to what? Absolute value of anything is always
Positive.
1. So here's a +1. Then we put the negative on it because it's on the outside, +2. So f of -1 is going to equal equal 1 because I added a negative 1 plus 2. Easy enough? Do the absolute values first when you're evaluating, okay? Okay with that, Josh and Sherry?
Yeah.
Okay. Sherry? She must be helping the boys get ready for school. All right, let's look on here. How about we do, yeah, let's do one with a fraction because I know you guys are going to freak out. Because it's a fraction. Freak out. So I'm going to do number 3, and then I think we will hit number 7. 3 and 7 before we go to page 4. So now they give us a rule on number 3, and they say our rule, we're naming it F again, f of x equals, has a negative, and on top, I have a 6x, and on the denominator is 2, at means this is what I want you to plug in. Okay. So what we're going to do is we're going to say, okay, I'm going to use rule F, but I'm going to plug in a negative 2 everywhere there's an x. So I'm going to copy this whole thing down just the way it is. 6, but I'm going to put a negative 2 here and then find the absolute value. You might want to make these longer so they don't look like 1s. Over 2. Now, since this negative is out in front of all of this, we're going to evaluate all of this and then take it times this negative 1 or put the negative on it after we're finished. So what do we do first here?
The 6 times the negative 2.
Yes, we're going to multiply inside of here and then solve this because this is our parentheses, right? So we have the absolute value of negative 12, yes, over 2. What's the absolute value of negative 12?
12.
12. Now we don't need the absolute value because we just found it. Over 2. So now we have f of negative 2, because we plugged in the negative 2, equals 12 divided by 2 is 6. Now we solved this whole thing, but we need this negative. Final answer should be negative 6. Y'all want to take? Yes. Okay. So it's still very important the order that you do this. Okay, and the absolute value is just like the parentheses. So any questions on this? Because it was a have one or you when I get started, then I'll ask. Okay. And I'm going to do, did I say number 7? Is that it? Make sure it looks a little bit different. Negative 6. And number 3. And number 7 looks like this. With F's again. That's usually what they call them. Now we have an absolute value of a fraction now, which isn't any different. It just tells us the order to do things. So f of 1, the absolute value, 12 over 4 times we need to do what's inside the parentheses absolute value sign. So 4 times 1 is 4, right? 12 divided by 4 is
3.
3. 3. But we haven't done the absolute value yet, so we have 3. Okay, and what is the absolute value of 3?
3.
It's always positive. That's exactly right. So it's 3. Just slow and follow the same order of operations that we've always done. What you have to do is remember the absolute values are always positive. Their roots, positive and negative, right? Absolute value, always positive. Okay. Are we okay with trying this page?
Oh, yeah.
Go to the next page.
I'm good.
Carrie.
It's a lot to take in, Miss Deborah.
Do what?
I said it's a lot to take in.
Yes, it is. And I think you missed a couple while you're taking care of the kids. So be sure and look at the YouTube, okay?
I will.
Yes, it is a lot to take in. But I think when you start on your own, it gets a little clearer. And then just ask questions. You know I'm always here. Well, most of the time I'm always here. All right, now we're going to solve equations. I want to see if they threw anything in here. All right, we're on this page now. And we're going to solve absolute value equations. Before we do number 1, I want to remind you what we did at the very first. We said if we have the absolute value of a number, it's going to be 5, right? But what's inside the absolute value brackets can also be negative, and it will still equal 5. Yes?
Yep.
Okay. So keep that in mind and listen to my explanation. So here's your first problem. It says the absolute value of x plus 3 is equal to 5. 5 is popular today.
It's a negative on number 1.
They said that x subtract 3.
Good. Rachel. Good. Thank you. Okay. Now, before you set up your absolute value solution, you have to make sure that only the absolute value is over here. If it says absolute value of stuff and then it says plus 4, you've got to get rid of the plus 4 first. Then you can do the absolute value stuff that I'm going to show you right now. Okay? But it has to be only absolute value there and an equals before you can start. Now, remembering that this stuff in here is going to be equal to 5, or this stuff in here can also be a negative, can it? It could be a negative 5 in there, and that would give us a 5. So here's how you do it. You say, okay, then it looks like we've got 2 different answers. So we're going to say we're going to say the stuff inside. We don't use the absolute value. The stuff inside could be equal to 5, or the stuff inside can be equal to a negative 5. Y'all see? Okay. If it's inside the absolute value, then you put the insides equal to the 5, but then you put the insides equal to a negative of whatever's there. And we're going to solve both of these. So we have that x could be 8. Are y'all with me there?
Mm-hmm.
So high now. Okay. Or when we solve this one, then we have x could be equal to -2 because I took -5 plus 3. So we have two answers to this absolute value. Now let's prove it. Okay? It says x can be equal to 8 to make that true. So let's go here and see if it works. So if I put 8 minus 3 equals 8 minus 3 is 5. What's the absolute value of 5?
2. I mean, not 2, but 3.
+5.
Okay, let's try our other answer and see if it works. It says if I plug in -2 right here, it should work. So I have -2 minus 3. What's -2 minus 3? -5. What's the absolute value of -5?
+5.
So both of those work. There are two answers that will work. So if you have an absolute value equal to something, you need to have the absolute value equal to the positive part and to the negative part. Have two answers. Now to make you feel better, then I'm not going to teach you anything else except this stuff. But I do want to call your attention to this type of problem. And this is just put in your hopper. What if I have the absolute value can the absolute value of anything be equal to a negative?
No.
So it's a no solution. You'll see? If it's only an absolute value over here equal to a negative, not going to happen. Because an absolute value can't equal a negative. It's always a positive. So what about this? What about this one?
Yeah, you got to add the 6 to the 3.
That is right. Even though the -3 is on the side that looks like equals, and we know an absolute value doesn't equal a negative, but in this case, remember to have the absolute value by itself, we have to get rid of the extra first. So when I have the absolute value by itself, I am going to have a positive. So it's okay. Y'all see? Does this make sense, Sherry?
Not really, but I'm trying.
Is there a question that you can ask me right now, or maybe when you start working?
I think I'm just gonna have to start working on it.
How about I look for one more? What do you guys think? Do you want to grab one? Let's do 14. Let's do 14 with that negative in it. Or 9. Which one do you guys want? Both? Both? Let's do 9 first, okay? Number 9. Here's the absolute value of -7 minus x. I'm going to make these longer. Okay, the first thing you're going to look at is the absolute value by itself. Yes, it is. Now you're going to look at, since it's by itself, is it equal to a negative?
Yeah.
No.
Come on, Rachel. It's equal to what? It's not equal to a negative, is it? It's equal to 5.
Oh,
Okay, which means I can work this problem is what I'm trying to get. Okay, so if the absolute value is by itself and it's equal to a positive, this is okay for us to work. Now we know if it's absolute value, I'm going to make 2 equations. I'm going to say, first of all, that -7, the insides are going to be equal to the 5. And the insides can also be equal to a -5. Now notice it's just the insides, it's not the absolute value. So this is okay. You see, I'm just doing the insides. So I want the x by itself. And so I'm going to add 7. So I have a -x equals 12. And remember, this negative in front is like a -1. So we have to get rid of it by dividing. This is multiplied together. So I'm going to divide by a -1 and divide by a -1. So I get that x equals -12. Yes? That's one of our answers. That will work if we put it in there. We want x by itself. So we add 7. We have a -x equals 2. This is -1, so I have to divide by -1. So now x also can equal a -2.
you can also,
I'm sorry?
you can also go and equals it into the -2.
It can equal a -2. If you plug a -2 in for x, that will work and equal 5. If I plug in a -12 over there, if you work it out, it will become a +5. And one more, number 9, and then I'm going to let y'all try on your own. I will be here the rest of class to ask any questions. Was it 9, did I say? No, I did 9. 14, you are correct. Number 14. The absolute value of -x plus 1 equals 9. Okay, we look at it real quick, do a quick observation, and we see that the absolute value is all by itself. We're not going to have to get rid of any extra stuff, so we're okay with that. If the absolute value is by itself, it can't be equal to a negative. We don't have a negative, so this is okay too. So I can work this problem, is what I'm trying to do. Trying to decide. And I know that if it's absolute value, I'm going to make 2 equations. I'm going to make the insides equal to 9. But I'm also going to make the insides equal to a -9. So I'm going to subtract 1, subtract 1. I have a -x equals to 8. But I can't leave the negative. And it's like a -1. It's that invisible -1. So I have to divide by -1 and divide by -1. So x can equal a -8 to make that true. So I subtract 1, subtract 1. So I have a -x equals a -10. But again, I've got to divide by -1. So
There may be a +9.
it's going to be a positive
Oh.
10
Yeah.
because it's divided by, not subtracted, okay?
Yeah.
So x can also equal 10. If you put it in there, the absolute value will equal 9. These are the two answers that will work up there in that absolute value. Are we sort of good? I mean, are you hanging on to the end of the rope?
I'm already on the edge of it.
Don't let go. Don't let go. Where are you on the rope, Sandra? Okay. Sandra's got her feet on that knot, so this is good. Where are you, Sherry?
I'm hanging on the end of it.
Okay. Okay. Josh, where are you on that rope? Are you at the top?
Yeah.
Okay. This is me for today. I'm going to stay on the Zoom as long as anybody wants to stay on. But if you need to go, I'm finishing up. If you're going, don't ever forget that I love you.
Oh, yeah.
Okay.